some radical functions, functions that involve the square root. Now, as a general rule, any kind of function can be graphed by plugging in numbers and sticking in some x's and getting y's essentially, and connecting the dots. Learning what a function looks like through a lot of examples gives you insight to the parent shape, and so that makes it easier for you to be able to graph. You can start to infer what things are going to look like with fewer points. Now, radicals are unique, or not unique, but different than, let's say, a line, because they have restricted domains. So, in particular, the things that are underneath the square root here, the x, we need the arguments to be bigger than or equal to 0, the things that are under the square root. So as I start to choose points to plug in, I'm going to choose two, or I'm going to have two things going through my mind. One is I need to use numbers that are bigger than or equal to 0, because that's the valid domain. And I'm going to use numbers that work well with square root, because I'm going to have to take the square root of the number, and certain numbers work well and certain ones don't. Technically, it doesn't matter which numbers you could use anything you want, but this will help me in the video to get good points, for lack of a better term, that work nicely. So 0 is bigger than or equal to 0. The square root of 0 is 0. Negative 2 times 0 is going to be 0, and 0 minus 1 is negative 1. Next, 1. Square root of 1 is 1. 1 times negative 2 is negative 2, and negative 2 minus 1 is negative 3. Next, not 2, not 3, 4. Why? Square root of 4 is 2. 2 times negative 2 is negative 4. Minus 1 is negative 5. Can you guess which number I'm going to use as my last one here? Not 5, 6, 7, or 8, but let's choose 9, because the square root of 9 is 3. 3 times negative 2 is negative 6. Minus 1 is negative 7. So this is going to help me to draw a graph now. So come down here, 1, 2, 3, 4, 5, 6, 7, 8, 9 on the x, 1, 2, 3, 4, 5, 6, 7 on the y, 0, negative 1 is located right here, 1 comma negative 3 is going to be 1, 2, 3, 4 comma negative 5 means I'm going to come to 4 and to negative 5, and finally 9 and negative 7. So my graph is going to look like a half of a parabola going that direction. Okay, same reasoning. Let's do it again with a more complicated thing under the square root this time, an x minus 1. Notice x minus 1, I need this to be bigger than or equal to 0. So by adding 1 to both sides, I'm going to need, or want I should say, x bigger than or equal to 1. Plug in 1. 1 minus 1 is 0, and 0 times negative 1/2 is negative 1/2. Next, I'm going to stick in the number 2. 2 minus 1 is 1, and 1 times negative 1/2 is negative 1/2. Whoops. This was actually 0. My mistake. Anything times 0 is 0. Not 3, not 4, but yes, 5, because 5 minus 1 is 4. Square root of 4 is 2, and 2 times negative 1/2 is negative 1. And finally, not 6, 7, 8, 9, but let's try 10, because 10 minus 1 is 9. Square root of 9 is 3, and we get negative 3/2. So for this one, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 along this axis. And down this axis, we actually got to get down to just about negative 1.5. So maybe we'll go negative 1, negative 2, different scaled axes. So 1, comma 0, 2, comma negative 1/2, 5, 1, 2, 3, 4, 5, comma negative 1, and then 10 comma negative 3/2. So can you see how the graph actually looks very similar to the other one? It's the same general shape of half a parabola. Okay, you try one on your own. Pause the video and see if you can do 3 times the square root of x minus 1. Notice x minus 1, if we wish for this to be bigger than or equal to 0, that means we really want x to be bigger than or equal to 1. So if I make myself a little t-table over here with an x and a y, we're going to plug in numbers bigger than 1. So let's plug in 1. 1 minus 1 is 0, and 3 times 0 is 0. 2. 2 minus 1 is 1, and square root of 1 is 1 times 3. Next, I'm going to plug in 5, because 5 minus 1 is 4. Square root of 4 is 2, and 2 times 3 is 6. And finally, we'll plug in the number 10, because 10 minus 1 is 9, and the square root of 9 is 3. So when we get 3 times that, we are going to get a value of 9. Coming over to our plot now, x is up through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y is up through 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 0, 2, 3. 1, 2, 3, 4, 5, 6, and finally 10, 9. So this time the graph looks like this. Again, half a parabola, but this time it's moving upward instead of downward.